this is Pierre-André Mathieu, and I'm here to show you how I set up a jump system like you see in Devil May Cry 3, Devil May Cry 4, and Devil May Cry 5. I know a lot of you people have a hard time in trying to get the jump system working. One person on Discord taught me on why his jump system isn't working, and I've been thinking maybe I should build the jump system step by step. So yeah, I'm going to show you how this is done. Okay, so I have what's called BPI, also known as Blueprint Interface. So if I open it, I'm showing you the blueprint interfaces in which I created. In case if you need to know, I simply right click, then go to Blueprint tab and click on Blueprint Interface, and that's it. You can rename the blueprint You can rename the blueprint interface however you like. It's all up to you, really. Anyway, what I have here is the player character blueprint interface. This interface allows me to set up functions that are completely completely exclusive to the player character, like the left thumbstick axis, for instance. Exclusive to the player character blueprint, the left thumbstick axis is a function that allows me to move the character with the use of the left thumbstick. Within the, say, player character controller, I can use that very same function through get player character, and needless to say, it's a very effective method to use, especially if I were to create something more modular and more optimal. Going back to the player character blueprint, I'm going to, since I have a new function, I'm going to rename it to face input. After I do that, I'm going to click the face input again and add a new input arrangement, and I'll rename it press. I'm going to add a new enumeration based on the face input. So I'm going to open enumeration folder, right click, then go to blueprint tab and select enumeration. Then I'll rename this enumeration to face input type. Once I got that down, I'm going to double click that, and since the face input revolves around 4 face inputs like you see on PlayStation or Xbox, I'm going to add 4 enumerators. This one is jump, second one is dodge, third one is weak attack, fourth one is strong attack. Once I have 4 of these down, I'm going to save what I have here before I go crazy. Back to the player character blueprint. Since I add a new enumeration, sorry, it's only fair that I add a new input arrangement, and this input arrangement should be face input type. This new parameter should be renamed face input type. Once I have everything down here, I have to compile, then save everything. Moving on to the player character, I have what's called class settings. So clicking this, I have to go to interfaces and add implemented interfaces. So what I need to do is click add, and it'll show me the rest of the blueprint interfaces, but I only need the one that I've created. So I'm gonna search player character. Well, I already have that. Anyway, if you search for the one you created, which is the player character that I created, this blueprint interface, all you need to do is select that blueprint interface that you created, and you'll see it right here. Now that I've added the player character blueprint interface, I'm going to find event face input, and there it is. Before I put it to the test, I'm going to need what's called a print string. Then duplicate that. This is for debugging purposes, to see if it works. Then going to player character controller, I'm going to add a jump. Which is the enhance input. By the way, in case if you're wondering, I transfer this coding from the original character blueprint, which was originally named blueprint first person character. It originally had that on the event begin play, which is the add input mapping. In my opinion, it shouldn't be on that player character. The input mapping should be on the player controller. Of course, everyone has their own preferences. I'm not gonna judge. I'm gonna use this to extract face input type. Then connect these together. Now let's see if it works. There we go. It's working. Now that I know that it works, I'm going to set up the jump system now. I'm going to search for switch, and it automatically shows. After that, I'm going to extract a node from jump and search for play and a montage. Going to content browser, I'm gonna go back and click characters. What I need to do is I'm going to create an anim montage. Then create a new folder. Then send this montage to anim montages folder. Gonna adjust the blend time for this montage just to make it faster. Once I have that, I'm going to insert this anim montage to the play anim montage. I'm going to test it out to see if it works. And it does work. The next part is where I set up the jump system piece by piece. In order for me to do that, I'll need a branch, then link the press from the event face input to the condition of the branch. Now that I have a branch, I can use it to determine whether I press the jump button or not. If it's false, I'll stop jumping. I may have to remove this, or I may have to keep it, depending on the situation. Anywho, let's stay focused. I'm going to bring out another branch. Then bring out can jump. Then use this. I'm going to test it and see if it works. It does work, but it only works once. This is why I'm going to add a new folder and name it anim notifies. I'm gonna right click, click blueprint class, and then search for anim notify. Then click it and select it. I'll need this movement because I'll be using this animation notify to determine the character's movement. I'm going to click override and then receive notify. From here, I'm going to extract a node from mesh component. Type in get owner. The owner is characters. I'm going to place a check mark on that. For now, I'm going to need a jump. Then go to the jump start and a montage. I'll put this new animation montage to the frame in which I stop right there. I'll change this to a branching point and let's see if this works. It does work, but it's missing something. So I'm gonna go to character folder, add a new function, and name it release buffer. Then inside I'm going to add a new variable, and I'm going to call it input buffer. The default value for input buffer should be -1. Then I'll get input buffer, extract node, and type in switch on integer. I'm going to uncheck this because I don't need that. From 0, I'm just going to set input buffer and set it to -1. I'm gonna right click, get player character, gonna extract that node and type in face input. Place a check mark and organize it. Just in case, I'm gonna have to make sure if it's valid. Now I'm gonna go to force land, Alright, let's break down this function. The force land function is likely called upon from other parts of the character blueprint logic, as it needs to be explicitly set to a landed state. This node sets the value of a boolean variable known as airborne, in which I named. This variable is connected to a red circle indicating that boolean value, in which is not connected to anything, which can only mean that it will default to its unchecked or false state when the function is called upon. Thus, the node is setting is airborne false. This function initialize animation is being called after the isAirborne variable set to false. It most likely plays a role in updating the character's animation state based on whether they are considered airborne or not. And I'm going to double click this to give you an idea what this function is inside. This function may not have a lot of stuff, but I'm going to add those existing variables later on, but I'm going to tell you what it is. As displayed on the force LAN, this function is called upon to update the character's animation state. This node, float time, sets the value of a float. Its input value is set to 0. This inherent node, jump max hold time, sets the value of a float as its input is being set to 0. So what does this function do exactly? The initialize animation function and performs the following actions. It resets the float time. By setting the float time variable to 0, it likely tracks the amount of time the character has been floating or airborne state where that specific character might have limited movement options or subject to different physics. By resetting it to 0, it suggests the character is no longer in such a state or is transitioning out of that state. Additionally, it sets the jump max hold time variable to 0, which likely controls the maximum duration the player can hold the jump input to achieve a higher jump. By resetting it to 0, it indicates that the character is no longer holding the jump button or that the window for a charge jump has ended. Its purpose, when called upon on the character's grounded airborne state, changes or whenever certain actions are initiated or completed. In resetting these time-related variables, it makes sure that the character was floating. The float time being resetted would likely trigger a transition out of that movement mode. The jump max hold time being reset prepares the character for the next potential jump input, ensuring that any previous held input doesn't unintentionally affect the new jump. These variables resets likely feed into the animation state machine, telling it to transition to the appropriate grounded or default movement animation. In short, this function in this context is responsible for resetting key time-related variables that influence the character's movement and animation states, likely as part of a transition to a grounded state or the preparation for new movement inputs. The capabilities, as you see in my third tutorial that deals with dynamic action capability system, ensures that the character can do a lot of stuff in terms of overall combative expression or other forms of expression. And after the capabilities, this node connects to what is called the gravity scale, which comes from the character movement function. I'm going to explain how these two work within these systems. Okay. I'm going to explain how these two work within this system, though what I'm about to say may not make sense to you. A Boolean input that is not connected, meaning it will be default to false, but that's not entirely true, because the default value is true, which means that a Boolean input that is connected remains true. The same is said of enemy step, burst, and trigger. What this function does is it lightly checks and potentially updates a lot of character capabilities or states in relation to movement, combat, or interaction within the environment. This function suggests that it may handle things like the ability to step on enemies, trigger burst effects, or interact with triggers. This doohickey right there it's connected to the character movement component of self, as I said, which indicates that I'm modifying a property of the character's movement system. The gravity scale from the character movement connects to target gravity output. It implies that the capabilities function determines the appropriate gravity scale for the character in this forced landing scenario. Putting these all together, the forced land function explicitly sets is airborne variable to false, updates the character's animation state to reflect the landed status, update, call upon capabilities function to potentially adjust various character abilities and states based on the landing context, considering factors like enemy step, burst, and trigger. Additionally, it sets the gravity scale of the character's movement component based on the output of the capabilities function, suggesting that the gravity might be temporarily altered or ensure to be the standard grounded gravity when the character is forced to land. The entire purpose of this function is to make sure that a smooth, consistent transition to a landed state character involves not just its airborne flag and animations, but also potentially affecting their environment capabilities and the influence of gravity. It could be triggered after various events such as ending an aerial attack or ability, recovering from a knockback or launch, in addition to specific gameplay mechanics that force the character back to the ground. To put it bluntly, forced land function ensures a comprehensive update of the character's state upon landing, as it handles animations, potentially adjusts various capabilities, and crucially sets the gravity scale through the character's movement component to make sure they behave as expected on the ground. Let's see how this function is used with the event tick. The event tick runs every tick as it checks if the character is either falling or flying using the character movement component, which I have right here, as it updates the is airborne boolean airborne boolean variable accordingly. In addition, it implements logic to potentially force a landed state under certain conditions. The event tick fires every frame, making this logic execute endlessly. It may seem redundant as delta seconds is already an output of the event tick event. It's most likely a leftover, or it may have been intended for some specific time manipulation that isn't fully implemented. This sequence node makes sure that the connected execution pins are fired in order. In terms of overall organization, the character movement variable is being accessed, implying a get node present, which provides access to the character's movement component. This function is falling checks if the character is currently within a falling state, whereas this function is flying determines whether or not the character is currently in a flying state. Their outputs are being used as the character movement component is being accessed. This node takes the Boolean outputs of is falling and is flying. It will output true only if the character is either falling or flying. However, if it's false, the character is likely grounded or performing non-aerial movement. If the character is falling or flying, the is airborne boolean variable is likely to be set true. However, if the character is not falling or flying, the second branch is executed. It checks the current value of the airborne variable. If is airborne is true, was previously true, but the character is now grounded, the true execution pin is followed. However, if it's false, then the false execution pin does nothing. If the character was previously airborne but now grounded, then and only then the is airborne variable is set to false. The force land function immediately is used after is airborne set to false. The force land function, in which I've shown you on my previous segment, is called upon the player character blueprint itself, which reinforces the landed state by potentially resetting any animation states and gravity. In a nutshell, the event graph continuously monitors the character's movement state. If the character is falling or flying, it sets the airborne to true. If the character is not falling or flying, it checks if is airborne was previously true. If so, it sets its airborne to false and calls upon the force land function to ensure a proper landing state. So the logic ensures that is airborne variable accurately reflects whether the character is currently considered airborne by the movement component and takes steps to finalize the landing process whenever the character returns to the ground. This is where event on landed comes into play. And what this does is it is triggered by the character movement component whenever the character successfully lands after being in an airborne state. This output provides information about landing event, such as point of impact and the surface hit. This is the same force land function in which I displayed on the section that talks about force land. Whenever the character movement component detects a successful landing, the event on landed event is triggered, which means it immediately calls upon force land function on the character itself. The event on landed is the direct signal from the movement system that a landing has occurred. By calling upon force land here, the blueprint makes sure that all necessary post-landing actions are consistently executed. While it might seem somewhat redundant because of the previous logic in the event tick was also handling is airborne flag and calling force land, the event on landed ensures that the landing sequence is properly initiated by the movement component's own event, potentially handling edge cases or providing a more reliable trigger. The hit output of event on landed provides specific details about landing. While this information is not directly used to call force land in this SIPnet, it could be used to trigger other landing specific effects, such as playing a landing sound, spawning dust particles, in other parts of the blueprint connected to this event. To put it bluntly, this logic shows a dedicated event that fires specifically whenever the character lands, as it directly triggers the force land function to make sure a consistent and comprehensive handling of the landing process, potentially alongside other landing related effects that might utilize the hit information, which reinforces the logic in which I showed in the event tick for managing the character's landed state. Back to the force land function, I'm going to drag release buffer and connect to the gravity scale. Now let's see if it works. Still not working. Alright, now I'm gonna go back to the player character and see if I can set up the rest of the whole jump mechanics. What I need to do is add a lot of things. So in dragging the node from can jump, I'm going to need an or boolean. Then from here I'm going to use an and boolean. For now, all I need is can enemy step which is supposed to be a get function. My bad. I'm sorry. The term I'm looking for is pure function. Anyway, I'm going to set, I'm sorry, not set, I'm going to get is airborne. Holding the B key, I'm going to left click to bring out another branch. Then I'm going to drag a node and get greater equal. I'm going to convert this to an integer, and the integer I'm going to use is input buffer. If this is true, I'm going to set an input buffer. And that buffer should be set to 1 since I'm using the jump button. Now, let's see if this is the case. Nope, not the case. I'm going to add another branch. Get an and boolean again. I need to make sure if the character is airborne. Going back to character blueprint, I'm going to add another variable called air jumps used. I'm going to change this to an integer. Then I go back, get a less than. I'm going to use air jumps used. I'm going to select an integer. I'll drag this out and rename it trigger active This is useful for whenever the character is entered into a powered up devil trigger like state. but I will get into that in a much later tutorial to see how useful this variable is. But for now, one shoe in front of the other, as they say. I'm gonna drag out true, then select increment on the executable actions, well, from executable actions, but you get the point. I'm going to go back to the character blueprint and add what's called a state parameter. Then I'll change this to a Boolean. I'm sorry, integer, not Boolean. And I'll duplicate it and name it substate parameter. What these two variables do is that it'll indicate what state the player's character is in based on certain actions that he uses, like jumping, attacking, or any other ability the character uses. It can also indicate states whenever a character is taking damage. So back here, I'm going to set state parameter. Then I'll have another branch, and bring this condition to the AND boolean. once I have that, I'm going to add air jumps used. If it's true, I can do all that, but if it's false, then all I need is sub-state parameter, and I'm going to set it to 50. But if it is true, then I'm going to add a sub-state parameter and set it to 51. I'll connect this right here. I'll use character movement and get gravity scale. Drag these execution links to the gravity scale. Between the gravity scale and play and montage, I'm going to set float time. And set it to -1. Then between those two, I'll have to initialize initialize animation. If this is false, then what I need to do is add another branch. Get is airborne. Then I'll set both state index and substate index. I'm sorry, what I meant to say was set state parameter and substate parameter. I'll set it to 1, then set this one to 0. I'll use input buffer. Then I'll use character movement again, only this time I'm going to set the velocity. To get velocity. Now need a jump. From the montage, I'm going to use capabilities. Then get is airborne. See how it works. For some reason, it's not working. I think I know why. Back to the character blueprint. The reason why I'm not jumping higher is because I didn't set up the add jump height, which was my mistake right here. So what I need to do is bring out branch. For the condition, I'm going to use greater than operator, then get jump time, jump max hold time. I'm going to use character movement to set velocity. I'm going to use add operator. Then I'm going to extract character movement to get velocity. From here, I'm going to need a multiplication operator. I'm going to need another one. I'm going to convert this to a float. Actually, I'll convert this one to a float, then connect it to multiply, and I'll use delta seconds. From here, I'll use custom time dilation. For the z-axis, I'll set it to 10,000. For the velocity, I'm going to set up a jump timer. From here, I'll need a clamp. I'll need I need a subtract. I'll use jump max, hold time. Minus by the operator used to multiply delta seconds and by the what I'm doing here is subtract max jump hold time subtracted by delta seconds multiplied by custom time dilation. So now that I have that, I'm going to compile and save and see what results I have now. Still not doing anything. Can't seem to understand why. I think if I can Nope, still not working. Maybe if I can nope. I forgot to maximize it. Still not working? I'll need something new. see. Nope. Going back to the movement animation notify, I'm going to erase this and try out a little something. I'm going to add a branch, promote to variable, and rename it set velocity. Then from here, I'll need character movement. I'm going to extract the node to get velocity. Then multiply it. I'll multiply it by inertia scale. Then add a little something. Actually, make that 2. From here, I'll get actor rotation. Actually, I'll get it from this. I'll rotate vector again. This time I'll use I'm going to promote to a variable and type in velocity, because that's what I'm going to use to determine the character's height in which the character's jumping. I'm going to multiply again. I'll select something. I'll convert convert it to an integer, and promote to a variable, then call it direction type. I'm gonna expose these. We'll have to set these axis values to 1 on option 0. Then from option 1, I'll need another select. Convert this to Boolean. I'll just add a new function and call it get player. I have to set player character. Convert to a pure function. Or better yet, I'm going to get walk threshold and get run threshold. This one on Z axis on the false, and the rest will be run. Once I'm finished with all of that, I'm going to set velocity between the two on the branch. Then use greater equal, convert it to integer, and promote to a variable and call it airborne index. I'm going to set movement mode extract it from airborne index and you select option 0 is walking, option 1 is falling, option 2 is flying. I have to make sure that the character is airborne. To add another branch, and I'll promote it to a variable and name it to set gravity. This again to set gravity scale. Promote to a variable. I'll leave it like that. To a variable and name it to set ground function. I need to set ground function. this. Before I do that, I'm going to set this inertia scale to 0.5 on both x and y axis. Okay, I have this set up. So what I'm going to do is set it to 0, set velocity. By default, I'll set it to 1270. Gravity scale should be 5. Falling lateral friction should be 0.5. The float time should be 1. Let's see. How come it's not doing anything? I now understand what went wrong. So I forgot to set the airborne index to number 1. Let's see if that works. It's working now. So the real question is, could I change this back to what I originally had? Out. I'll use this. Back to player character, I'm going to use stop jumping. delete this. Yeah, I was using jump timer because I was busy trying to fix the whole thing. Now let's see the results. It does still work, but not as much as the jump timer, I presume. So maybe, just maybe, if I can it really does the same thing. Alright, testing it out again. I have my jump, yes, but when I press it again, I keep jumping endlessly, and honestly, I don't like it. What I'm gonna do is open a new animation notify. I'll name it capabilities. Receive notify, extract a node from mesh component to get owner. Then I'll set characters. Actions. I'm gonna extract a node from here to make this. I'll promote all 9 of these to a variable. do, I'm going to add a branch. Move it to a variable, then rename it release buffer. I'm going to add a rewrote node, then extract it and get release buffer. Highlight that. I'm going to go back to the jump montage. I'm going to add capabilities. And we'll see how it works. Still not doing what I wanted. Maybe if I go to air jumps use, it's not it. Something's not right. Okay, after much thought and a lot of corrections that I made, I fully began to understand why that I seem to jump endlessly. Going to character blueprint, I have this function which enables enemy step, and it's using event tick to have this continuous flow. This boolean variable set enemy overlapping sets the variable. The input value is not directly visible, but given the subsequent logic, it's being set to false initially in this tick. For each loop, it alliterates through most likely the actor object reference, which stems from get overlapping actors. The class filter is of course the character blueprint, which is the blueprint that I'm currently using. What this means is it's getting all actors that are overlapping, as this character and the area of the character class, meaning the child blueprint that has the same class as character blueprint. This logic inside the loop is going to execute once for each overlapping character blueprint actor. The current character blueprint actor is being processed within the loop. As for the completed, I'm just going to leave it at that, since it's not really that important. The condition being checked on the output contains a node, that being set characters. If you don't know what that is, it's just a function in which I made in the class settings, and it stems from the blueprint interface I created called Blueprint Character Interface, which is right here. I created in my Blueprint Interface folder. if I double click, the return value for set characters is actually the character blueprint itself. So I have to right click, type in self, and get a reference to self, which I have so right here. I need to compile and save before I go crazy. But enough about that. Let's go back to how this works. With the contains node array, I switch characters, most likely an array variable within this blueprint, the character blueprint. What I did is extract a node from the return value, then connect that node to this output, not output, but input to the contains. Then once I've done that, I'm going to extract a node from the array input, promote to a variable, then rename this to switch characters. If this return value is true, the switch characters array can contain the current overlapping character actor. If not, then the character blueprint actor is false otherwise, and it'll just use enemy overlapping, in which I forgot to place a check mark there. If it's true, then the overlapping character is found within the switch characters array. If it's false, the overlapping character is not found in the switch characters array, and it'll just use the enemy overlapping, which is set to true. The logic, it detects and reacts to other character blueprint actors overlapping with the current character. At the beginning of this tick, enemy overlapping is likely set to false. It iterates through all character or blueprint actors currently overlapping with this character. For each overlapping character, it calls upon a set characters function and passing a reference to the current character, which can be used for various communication or interaction purposes between the overlapping characters. It checks if the overlapping character is present within the switch characters array. If it is, it sets enemy overlapping to true. which suggests that the switch characters array may hold references to specific enemy characters that trigger this enemy overlapping flag. After checking all overlapping characters, the switch characters array is cleared, which implies that the array is most likely used as a temporary buffer to track specific overlapping enemies within a single tick. The entire purpose of this system is used for various gameplay mechanics like proximity-based actions, meaning the enemy overlapping flag could trigger specific behaviors, or UI elements when the character is close to certain enemies. Interaction zones, meaning overlapping with certain character blueprints might trigger specific interactions or events. Enemy awareness, which could be a part of an AI system where enemies became aware of the player when they overlap. Special attack conditions, which is of course overlapping with specific enemies, might be able to enable certain attacks or abilities. With the use of switch characters array, I have a more targeted approach to detecting specific enemy types or individuals rather than just any overlapping character. The array is likely populated elsewhere inside the character blueprint based on specific game events or enemy properties. So, to put it bluntly, this event tick logic detects overlapping character blueprint actors, communicates with them, checks if they belong to a specific switch character list to set an enemy overlapping flag, and then clears that list, indicating a per tick check for specific enemy interactions. This is useful especially when performing a jump cancel upon an enemy as seen in the Devil May Cry series. Now going to player character, after adding enemy overlapping into my character blueprint, I decided to add this very same variable within my jump system. The part that's between this branch that determines whether I press the jump button, and this branch determine whether I'm airborne, and the jump max count less than the selective integers on the jumps based on whether or not I'm at a powered up state. Oh, and by the way, I decided to abandon the air jumps use count to use max jump count because I thought that why not use the inherent variables within the character blueprint. Anyway, back to this. With the enemy overlap, I'm able to prevent the player character for jumping as many times within the air. just to prove my point, I'm going to disconnect that and see how it works. Still double jumping. Okay. Maybe if I can disconnect this. Oh, still double jumping. Now let's see. Yep. As you can see, without enemy overlapping, I'm jumping as many times in mid-air, and quite frankly, that's not something any game developer would want in a character action game like this. It would seem too glitchy. So in order to fix this issue, I need this tick logic. Then add a new pin. Switch this link to the third one. Then add enemy overlapping between these two. Then compile and save. Now let's see what I have so far. There we go. Now you see, now I can only jump twice in the air, unless I'm in a powered up state that allows me to jump 3 times. That would be an exception to that rule, but other than that, no, I'm not in the powered up state. In fact, that power boost I can only show you on a much later tutorial. Inside the player character blueprint, I have is airborne, and it stems from the player reference, which is a boolean for player character, and it comes from set player character while using try get pawn owner. As for how I use this, I go to animation graph and I set slot default slot. I use this to fire up the animation from my montage including the jump, attack, dodge, and so on. So without that, I'm only doing this. But if I were to put it back, it has the jump animation. Now if I go to default, this is where I have the jump loop and jump end set up. From idle to jump loop, I have this transition is airborne, and it has to be used to transition between idle and jump loop. Like this. Wait, hold on. Let me see. Yeah. Maybe I can play it again just to have a clear picture. Yeah, I saw the jump loop briefly. From jump loop to jump end, the animation plays only when the player character is not within the air, and this animation fires. And from jump in to idle, this is where this logic comes in. With this transition, I can end the jump in two ways. One, either when I'm landing on the ground using this animation, or whenever I move with the left analog stick, the move speed, it fires. Let's see if this logic works. This is landing. This is where, as I'm descending from the air, I'm still moving. So now you got quite the gist of how the jumping system works, like what you see in Devil May Cry. If you enjoyed this video, Please like and subscribe to my channel for future tutorials like this. And what you take and learn from me is yours to do with as you see fit. Peace out and enjoy the rest of your day.